Hello, welcome to video number 5 of Unit 1, on pages 26 to 29, titled Limit-Based Continuity, Graphical and Analytical Approaches. So, for the function graph below, we want to fill in the table with the given information, and then write the three pieces of information that must be true for a function to be continuous at the point x equals 1. So what we're going to do together is actually just the first two rows of this, because they're the only two that you can see both the graph and the table on my screen. So starting with x equals -6, we want to know if the function is defined, and if so, what the value is. So this question is basically just asking me, what is g of -6? So if we look, g of -6 is a whole, so g of -6 is undefined. Next, we need to know what the value of the limit of x as x approaches -6 from the left of g of x. So from the left, our value is approaching 5. And now we want to know from the right, as we approach -6, what is our graph approaching? Also 5. So what is the limit as x approaches -6 of g of x? That answer is 5, because the left and the right, what's going on with my pen here? The left and the right both approach the same value, and that value is 5. Now, this is the question. Is g of x continuous at x equals -6 in this case? The answer is and I'm going to have you try and figure out where is the answer going to be yes, according to this table. Next, we have x equals -3. So our first question, we need to know what g of -3 is. In this case, g of -3 is 2, because that is where our closed circle is in our graph. Limit as x approaches -3 from the left is 2. And the limit as x approaches -3 from the right is -4. My pen has decided it no longer wants to write. Not sure why. -4. So now what is the limit as x approaches -3? The left hand and the right hand do not match, so that limit does not exist. Is this continuous? No. So what I'm going to do is I'm actually going to fill out that last column of the table for all of these values, and you have to figure out what are the three pieces of information that need to be true for that top piece. Okay, so you're going to fill out the rest of this table and then try to figure out what three pieces of information must be true in order for a function to be continuous at a value x equals a. Now, for the next page, the graph of a function g of x, pictured below, has several x values at which the function is not continuous. For each of the following x values, use the three-part definition of continuity to determine if the function is continuous or not. So what we are going to do, we are going to use all three definitions of continuous, to prove whether or not x equals 8, or x equals -8, x equals -6, and x equals -4 are continuous on this graph. So the first that we are going to check is if the value is defined at that x. So g of -8, if we go to g of -8, g of -8 is defined and its value is 4. Alright, so the second part of the definition that we need to check, the limit from the left and the limit from the right, to make sure that the limit exists. So the limit as x approaches -8 from the left of g of x is equal to, from the left, we got -5. And then the limit as x approaches -8 from the right of g of x, we've got, again, -5. So we can state that the limit as x approaches -8 of g of x exists because the limit as x approaches -8 from the left of g of x equals the limit as x approaches -8 from the right. All right, so now for the last part of our definition, we want to make sure that our answer to part 1 and our answer to part 2 are the same. So since g of -8 equals 4 and the limit as x approaches -8 equals -5, then g of -8 does not equal the limit x approaches -8 g of x. Therefore, g of x is not continuous at x. So we had to go through all 3 of these steps to make sure, and it turns out they're not. So now, number 2, we want to see if x equals -6 is continuous based on the 3 definitions that we use. So our first definition, we need to make sure that g of -6 is defined and figure out what its value is. So g of -6 is defined and its value is -7. G of -6 is defined and its value is -7. Step number 2. We want the limit from the left and the limit from the right. So limit as x approaches negative 6 from the left of g of x, and the limit as x approaches negative 6 from the right, g of x from the left, we're approaching negative 7 from the right, we're still approaching negative 7. So the limit x approaches negative 6, g of x exists because the limit x approaches negative 6 from the left, g of x equals the limit x approaches negative 6 from the right, g of x. So now, step 3. Are they the same? So, since g of negative 6, actually, let me write this on the next line so that it's all one big thing. Since g of negative 6 equal to the limit as x approaches negative 6 of g of x, they're both negative 7. I have no idea what's going on with my screen today. Therefore, g of x is continuous at x equals negative 6. Alright, so now for number 3. So for number 3, first part, we need to figure out what the value of g of negative 4 is. So g negative 4 exists, so it is defined, and it's, oh my goodness, this is getting really annoying. Value is negative. Number 2, the limit as x approaches negative 4 from the left of g of x equal to, from the left, negative 5. The limit as x approaches negative 4 from the right of g of x equal to negative 2. So the limit as x approaches negative 4, g of x does not exist because the limit as x approaches negative 4 from the left, g of x not equal the limit as x approaches negative 4 from the right, g of x. Therefore, g of x is not continuous at x equals negative 4. So notice how I didn't have to show or prove that third step, because once one of the other two steps don't work, we can automatically assume that we are not going to be continuous. So on the next page, we want to use the three-part definition of continuity to determine if the given functions are continuous at indicated values of x. So for number 4, we have a piecewise defined function. And we want to know if at x equals -2, if we have continuity. So we're going to go through the 3 steps. Same way we would if we were on a graph. We're going through the same 3 steps. So the first step is we want to figure out what is f of -2. So f of -2, we have 3 different restrictions. The first is for x is less than -2, second is when x equals -2, and the third is when x is greater than -2. So since we're looking at what f is at -2, we're going to use that second function. So we'll have 3 times -2, 2, which is equal to -4. So f of -2 equal to -4. So just by writing that statement, we do not then have to state that f of -2 is defined, because that statement says that it's defined and gives us the value at the same time. So next, we have the limit. So we want the limit as x approaches -2 from the left of f of x, which means we're looking at values that are less than -2. So we'll use that top equation. So we have -2 square root of -2 plus 6, which is equal to -2 plus 6 is 4, square root of 4 is 2, -2 times 2 is -4. Now the limit from the right, which is going to ask for x values greater than -2, so we'll use that bottom equation. So we have e to the -2 plus cosine -2 pi, which is going to be equal to 1 over e squared plus 1, which is definitely not going to be -4. So we can conclude that the limit x approaches -2 of x does not exist, because the limit as x approaches -2 from the left of f of x is not equal to the limit x approaches -2 from the right of x. Therefore, f of x is not continuous at x equals -2. So now what I want you to try is number 5. I want you to try number 5. You're looking at continuity at x equals pi. So using this piecewise function, use the 3 definitions of continuity in order to help you figure this out. So